Good morning, class. This is Mr. Walker here, and we are talking about our next section of our notebook. This section is dealing with solving equations. So we're talking about the most basic to the more, complicated versions of equations that at least have x to the first power. Now, when we get further into, the year, we'll deal with other powers of x, but for right now, we got to make sure we get the basics down. So first thing we are going to be doing, we're taking a look at some vocabulary words. Now, unlike our last part of the unit, we're only going to deal with these two in this method. So, we are going to be dealing with inverse operations and equations as our words. And just like before, I'm giving you links to where you would be able to find the definitions. So I'm going to do one of these with you, and you're going to do the other one on your own, okay? So let's pull up the one for equation, because I feel like that's something we can all get a hang of. So we got an equation is something that says that two things are equal. So that's a pretty simple definition. So over here on equation, I'm going to click that, and let's just paste that information right there. An equation says that two things are equal. Now, remember what we did with characteristics. Characteristics are just other facts that help us determine what something is. So, one thing we know, it says it will have an equal sign. So we can put that right there. So we'll have an equal sign like this. And like this, we're going to be giving an example. That's right here. Just so we finish off that statement. Now, this also works for our example column, so we will possibly use that over again. All right, so next, like we did before with examples, we can either write out an example or we can copy and paste a picture. I'll copy and paste one personally. So I'm going to copy this image and I'm going to bring it right on over here. Make my life a little easier. Now we wanted a non-example. So a non-example of an equation would be like what we had before with expressions. Expressions can be turned into an equation just like this example gives us here, but it does not have the equal sign and whatever else is over here. So what I'm going to do, I'm going to copy this over. Actually, I'll just type it out. That might be even a little easier. So I could just say 3x plus 2. That's an example. I could say 1 plus 1. That's an exclamation. X, 1 plus 1. Or I could say just x. Now the differences between this and what we have over here is that these all don't have the equal sign in mind. They're not telling you to solve anything, okay? These are just what they are. All right, so that's it for this. I'm gonna let you guys do the one for inverse operations on your own. Now, going to the next part of our vocab section, we have this chart right here that goes over properties that we are going to be seeing as we go through with our next part of our unit. So, if you notice right here, we are going to be having a link here and a link here to fill out our information. Now, let me show you where we're getting this information from. So, when we click the link at the top of this chart, this will open up to this website here. And then when we open up the link to this chart, it'll open up the link right over here. So we're going to go over how to get these informations, and I'm going to let you guys fill out the rest. So, properties of equality. These are more or less the more technical ways of we looking at how we're going to solve something. So, what steps do we take? What do we do here? What do we do there? Things like that. So, over here we have in this column, what is the name of that particular rule? There are 6 of them. There are addition, subtraction, multiplication, division, the distributive, and substitution. In the middle, we're going to give the definition, and then on the right, we are going to give an example of that. So we're going to go through addition and subtraction with you. So I'm going to click my link, and it's going to bring me right over here. Now, up top, we are going to scroll down to where it says properties of equality. Okay. So this right here gives us the 1, 2, 3, 4, 5, and 6 that we are looking for with its definition and its examples clearly written out. So first off, we're looking at our definition for addition. So it says if A equals B, then A plus C equals B plus C. So basically it says if you got two things that are equal to each other, then if I add them to another number, they should always be equal to each other. So in this example here, we are using this property to go about finding out what x is equal to. Now, in a way, when you do this, it's kind of doing the inverse of what you're doing to find out what x is. So they give us if x minus 3 equals 7, then x equals 10 by adding 3 to both sides. So what it tells us, this and this are both equal to each other. So if they're both equal to each other, this side and this side, if I add the same number to both sides, then that'll make them still equal to each other. See, because if I add 3 over here, and if I add 3 over here, it's still equal. I'm still doing the same thing on both sides. So let's take a look at that. We're going to copy it here. And let's close that out. And then for addition, we're going to paste that rule right here. Pretty simple. So if you're adding the same thing to both sides, you'll be able to solve it because they are doing the same exact thing. So this is a more technical way of, telling me what the steps are to solving something. And I will, give you a little quiz over this eventually. All right, so we got the rule for addition. Now we're going to look at the rule for subtraction. So the rule for subtraction, if A equals B, then A minus C is equal to B minus C. So just like the previous rule, if we got two things that are equal to each other in an equation, so one side here is equal to this side, if I subtract the same thing from both of those sides, then they are going to still be equal. So let's copy that over, and then we're going to take a look at that example. All right, so it says if x plus 2 equals 11, so we got this side here is equal to this side, then x will equal 9 by subtracting 2 from both sides. So what it's saying is this will give me that answer because all I'm doing is subtracting the same thing from both sides that I don't want to find. I already know what 2 is equal to. So if I get rid of this 2 here, and it gets me the x by itself. So that way I'll be able to find out what x is. So we're going to copy that over, copy, and then we're going to paste. So that's the first 2 of these 6 properties of equality that you're going to go through and solve, define in your book. Now, over to the right, we are going to be dealing with exponent properties. Now, the reason that we're dealing with this is because I want to make sure that you do know this going forward, because this will come up a lot as we go through Algebra 2. So, when we click this link, where it's going to bring us is this page right here. So this quick chart is actually going to be copied back over into our notebook. So we have 7 different rules that deal with exponents. Now, do we deal with them as often as we would like? No, but we're still going to make sure that we know what they are. So I'm just going to go through and copy them over here in our chart. That way, we know what goes to what. Now, for this part of the chart, we have the rule column. For the symbolism column, it matches up just the same thing as over here. This is just an example of what would happen in that particular rule. And then in plain English, that is going to be actually describing to you what it is. So after you copy, we're just going to do the first couple here. And I know I gave you guys a lot more going through. Actually, no, I think I gave you 7. 1, 2, 3, 4. Yeah, I gave you 7. Yeah. So we're going to do the first 2 together. Okay. So we are looking at the 0 exponent rule. It gives us a picture where it says x to the 0 equals 1. And what this means in plain English, all numbers, not 0, raised to the 0 power will equal 1. So anything that is taken to the 0 power will be 1. It doesn't matter whether or not it's a variable. It will equal 1 as long as it is not 0. So we're going to take that bit right there that was in plain English. We're going to put that right there. And then what we're going to do, we're just going to take this. Oh, let's copy that. And let's see if that'll paste over correctly. There we are. Now, for this, we're just going to have to deal with this box here quickly. I don't know why that popped up. Let me get rid of that. All right. And let me drag that right on over. So just some fair warning, that does that for some reason. Okay. Very simple. There we go. All right. So that is the first part done right here. Okay. So fair warning, you'll see that pop up more than once, more than likely, like that whole thing that happened with the box and the separate little part of the table there. All right, let's take a look at this next one. All right, so for the negative exponent rule, they show us this x to the negative m equals 1 over x to the m. So what this is really telling you that a negative exponent tells you that the factor, whatever that number is as its base, is on the wrong side of the fraction bar. So we know that everything is essentially a fraction over 1 if it's a whole number. So imagine there's an imaginary 1 right here. If you see a negative exponent attached to that number, what that means is we have to take that x and the exponent without the negative, and we need to move it to the bottom part of the fraction. And then on top, we're just going to put a nice, neat little 1. So this right here comes up a little bit as you're dealing with exponents of a higher power and also things that might have a negative. So we will see that pop up from time to time. Okay, let me undo that. Let me get this. There we go. And this is a image, so I can just copy and paste that right over here. Boom. Okay. So that's the first 2 right there. You guys are going to go through and knock out the other rules here, as well as the other rules here on your own. All right, good luck, folks.